There's lots of different topics in advanced networking. Let's take a look. We're going to talk about VLANs, or virtual local area networks. They're very similar to subnets or subnetworks, except for we're going to be introducing them through a layer 3 switch. And we have inter-VLAN routing, which is a way of routing from one subnet to another within a single switch. Virtual private networks are very important to today's modern offices. We're going to talk about port bonding and mirroring, which are techniques that we can use in switching, as well as quality of service, so we can make sure that the priority traffic gets the most amount of bandwidth based on our needs. Intrusion prevention and intrusion detection devices are parts of many offices nowadays. Let's discuss virtual local area networks. VLANs allow network administrators to divide our network into separate logical subnetworks. And we do that on our local area network, where all our hosts are connected to a switch and members of the same subnet. And then if we have a separate subnet we would like to connect them to, then we create a second VLAN. So by default, when we start to create VLANs, the first subnet is going to be VLAN 1. Then when we add more subnets, we end up with better performance, and that's because we block a lot of broadcast traffic, amongst other things. VLANs are numbered from 0 to 4095, and once again, the default VLAN is VLAN 1. Using routers, we need to connect a router between each subnet division. Then we need to connect a switch to each router, and this requires additional configuration and equipment. So take a look. Instead of using VLANs in this particular case, we're doing the same thing as a VLAN does, except for we're dividing it up using routers. So we see each of the routers is separating our different networks. And in this case, we have 4 different networks, 10.1.1, .2, .3, and .4. And the problem with this is it requires a lot of configuration and a lot of extra devices. So instead of using routers, let's use VLANs with layer 3 switches. Here we have the same thing as the router configuration, where it works with all those different 4 subnets. However, we now have a lot less hardware and a lot less configuration. But we accomplish the same thing. Our layer 3 switch is doing the work of a switch by providing the switch and trunk ports, as well as the job of a router by dividing and routing subnets to the switches. So we see our layer 2 switches all around our layer 3 switch. Now what that means is our layer 2 switches are layer 3 aware. They're aware of the various different VLANs, but they can't necessarily route between them. However, our layer 3 switch with inter-VLAN routing can do that as well. There are many advantages to a VLAN. Of course, we have cost savings due to less equipment. Less equipment equals cheaper price. Then we have less configuration because there's less devices to deal with. So on a router, if we wanted to change subnets or add an additional subnet, we may need an additional router. But with a switch, each one of those ports can route to a different subnet, or in this case, we're now referring to them as a VLAN. And data and voice can be segmented on the same port. So on some higher end switches, such as the Cisco 2000 and 3000 series switches, you can segment the traffic between data and voice. So you can have more than one VLAN running on the same port at the same time. However, one has to be designated data and one has to be designated voice. And that can save you a lot of money, because in many networks that I've seen, we've had separate networks for the voice and separate networks for the data. But now you only need one network. You only need one physical local area network with all of this hardware that's running using VLANs to segment the different subnets. Let's take a look at a Cisco layer 3 switch, where we will add a virtual LAN to our switch and to our network. Here we have a layer 3 switch, and it's using several different VLANs. Now this is a 3000 series switch that is inter-VLAN capable, so we can route between VLANs 1, 2, and 3. Now we see that VLAN 1 has an IP address, and we see that VLAN 3 has an IP address, and we see VLAN 3 is being used as a wireless guest network. You can add a description as you see here. So in this case, we see VLAN 3 is being successfully used to separate guest wireless traffic from the internal wired and wireless traffic. We see VLAN 1 is the default wired traffic. And VLAN 2 was created, but it was never configured with any type of IP address. Let's create a brand new VLAN and add an IP address to it. We'll start by typing in INT for interface, and we'll type VLAN, and we'll say 4 because we know 4 is not being used. And that's all it is. I just created a VLAN. Now I'm going to give it an IP address. IP address, and we'll give it a 172.16.20.2. Give it a subnet mask, and hit enter. Now we'll exit backwards, and we'll do a show run again and get back to that VLAN section. There we are. It's kind of a fast forward there through it. And take a look. There's our interface VLAN 4, and there's our IP address. Now if I do a show interface VLAN 1, for instance, I can see that VLAN 1 is up, and I can see the protocol is up, and that means that it is working just fine. But if I do a show interface VLAN 4, I can see that it's down and down. So the VLAN protocol is down as well as the physical line is down. And the reason for that is because I have not assigned it to any particular port. Once I assign VLAN 4 to a port and then I plug something into that port, it will automatically bring my VLAN up and I'll be able to start working on it. And then I can transmit traffic between VLAN 4, VLAN 3, 2, 1, however many VLANs I have, where I've set up the ability to set those VLANs without any kind of access control list blocking me. So that's how simple it is to create a VLAN on a Cisco switch. Inter-VLAN routing is a way to forward traffic between different VLANs by implementing a router in the network. They do the work of a router, but they also do the work of a switch. And it forwards traffic between VLANs. So for instance, if we have VLAN 1 with 192.168.1 and VLAN 2 with 192.168.2, we could designate the first port for the first VLAN and the second port for the second VLAN. And the inter-VLAN routing capability of that switch allows us to route back and forth between the two different VLANs. Less expensive switches are what's called layer 3 aware, but cannot route between the VLANs. We need to have a layer 3 switch that is inter-VLAN routing capable. Various vendors label their layer switches different ways. For Cisco, for instance, the 2000 series is layer 3 aware, but only the 3000 series can route between the VLANs. If you don't have a router in your network and you use multiple VLANs, you need at least one inter-VLAN capable layer 3 switch, or in this case, the Cisco 3000 series, or the subnets will never be able to find each other. I did have a customer that had a lot of Cisco 2000 series layer 3 aware switches, and a single layer 3 switch that was up in an attic that averaged 120 degrees in the summer. Well, one day that Cisco 3000 series finally quit, and the Cisco 2000 series switches were all aware of the various different VLANs, but they had no way of finding each other. And since I didn't have another Cisco 3000 series that was in stock, I had to order one. I took a router and just created what's called sub-interfaces, which did the same job as the Cisco 3000 series switch, and the 2000 series layer 3 aware subnets were once again able to talk to each other. It wasn't an optimal way of doing this, but it was a way that worked while we were waiting for a Cisco 3000 series switch to replace the one that went dead up in the attic. So every network has to have at least one layer 3 switch that is inter-VLAN capable, so it acts as a router, or you actually have to have a physical router. Virtual private networks are a way that a modern office can allow road warriors to connect to an internal network. When we send data across the internet from one location to another, it can be easily intercepted if it's sent in clear text. So we need to encrypt our communications, and we can do that using virtual private networks. There's lots of different types of virtual private networks using various protocols depending on which vendor you use. When you go to connect your VPN from a hotel, you may find certain types of VPNs are blocked due to a lot of overhead and limited speed and resources that location is going to provide you. Two ways to connect your VPN are either site-to-site, or office-to-office, or client-to-site, which is where you'd use your PC and connect into the office. Site-to-site is great for organizations that have multiple locations. I've set up many site-to-site VPN tunnels. The data can be encrypted by a firewall, VPN concentrator, or just between two servers. Data leaves one location and gets encrypted, and when it reaches the other location, a separate device that matches the first one decrypts it. The data is now safe from any man-in-the-middle attacks. If any data is intercepted, the person that intercepts it won't know what they have. And when you have one of these site-to-site VPNs set up, what's great about it is that you can communicate from office to office without even realizing what's happening in the background. You don't have to do any special setup on the client side once the site-to-site connection is done. Data travels both ways in a site-to-site VPN tunnel. And by default, there are no access control lists between the two locations, which means that data is going to flow freely without any firewalling done between, despite the fact that you see two firewalls here. The firewalls still protect the network from the outside, they just don't protect the network from each other unless you set up special access control lists. Client-to-site works in a very similar way, but it uses a computer to connect from any internet-capable location. A software client on the PC or mobile device encrypts the data, and then it sends it back to a VPN device on the other end, where it can be decrypted and delivered. Sometimes we use a third-party client, such as a Cisco VPN client or a SonicWall VPN client. Other times, if our VPN device is a Windows server, then we can use the built-in Windows client to connect to the Windows server and just pass the traffic through the firewall. There are many different types of VPN protocols. We used to use point-to-point tunneling protocol a long time ago. However, it's been hacked so many times that it's now no longer a reliable, safe protocol for virtual private networks. Now, Microsoft still has it on their servers, even though Cisco took it off of their firewalls. But Microsoft upgraded the encryption level to be a little bit more secure, but it's still not necessarily the best secure VPN out there. Ipsec stands for IP security, and it is a very good VPN protocol. The problem is it's a little bit heavy as far as it takes too much overhead in order to get an IPsec tunnel to work properly. For site-to-site, it seems to work fine, but for client-to-site, many hotels and other public organizations that allow you to connect to their internet are blocking IPsec because of that massive overhead. IkeVPN is a great virtual private network protocol because it allows you to use a very slow connection that may get disconnected a lot, such as dial-up or very slow leased lines. And the reason it's great for those types of connections is if you do get disconnected, it will reconnect without having to re-authenticate. Layer 2 tunneling protocol is a very popular one. Once Apple, for instance, dropped point-to-point tunneling protocol, they required L2TP to connect using VPN. Secure Socket Layer is the only option that won't get blocked from a hotel or other public location, and that's because people would be very unhappy if they were unable to do any shopping using sites that were protected with a certificate on port 443. Well, SSL VPN also operates on port 443 using a certificate, and so that's the best option that we have found for connecting from hotels and other public locations if we're going to do a client-to-site connection. And even though we still refer to this as SSL or Secure Socket Layer, the latest version is using the Transport Layer Security, which is the newer version that is far more secure and has better encryption. But most likely we'll still refer to this as SSL for the near future. Internet service providers also provide VPN options, and the first one would be the MPLS. MPLS stands for Multi-Protocol Label Switching, and it allows for good connectivity between multiple offices. It's privately managed by the internet service provider. It has low latency, although that really depends on the speed with which you sign up. Usually MPLS services also come with a guarantee of availability, such as 99.999%. Encryption is done at the internet service provider, so we don't need to have a VPN setup on our end. So we don't need to have two firewalls setting up a site-to-site tunnel. All of that VPN can be done at the internet service provider. MPLS is expensive compared to traditional internet because it lacks multiple routes. You may have heard of another product called SD-WAN, and that stands for Software-Defined Networking in a Wide Area Network. SD-WAN gives us all the same advantages of MPLS, but it can be less expensive and faster due to the ability to route between multiple different paths. It's also encrypted at the Internet Service Provider. Port bonding is going to allow us to take multiple connections and bond them together for faster speed. Port bonding is also known by the term link aggregation, and you can do this in Cisco by creating a link aggregation group or what's called a lag. Single network connections between switches and routers can get filled up by sending too much traffic between devices over a single cable. By bonding two or more connections, you double the bandwidth between them. You can even add additional connections to bond as needed for better bandwidth. It's important to note that we haven't increased the speed. All we've done is increase the amount of data that can travel between the devices, which makes it feel like it's running faster. It's sort of like the difference between a pipe that may be 6 inches in diameter and a garden hose. You're not pushing the water through any faster, you just have a wider way for people to get through. Let's take a look at what a standard Cisco lag configuration would look like. This command is going to create a port channel where we will bind our two interfaces together. We create a channel 1 called 1, and we choose our encapsulation type and give it a VLAN ID. We then allow VLAN traffic through this port, or you can specify which one. We trunk the port because it's going to be connected to another switch. Switch-to-switch ports are always configured as trunks, but switch-to-computers are configured as switch ports. And this is the complete configuration for setting up Cisco lag. These next commands configure ports 1 and 2 that are going to be bound by the new group we just created. We're now going to be able to send traffic between switches at twice the bandwidth. The same config will need to be performed on the other switch as well. So here we see switch port 1 and switch port 2 on the first switch. You'll go on to your second switch where you connect these other two cables at the other end, and then you'll configure it the exact same way. I've done this before between floors. I had a client where he wanted to push out new software image updates to blank hard drives on new computers. And doing it over a single port just filled up the pipe so much that people between the two floors couldn't get any work done. By adding this second cable and doing a link aggregation or a lag, I was able to double the amount of bandwidth, and that allowed more of the imaging to take place without slowing down the other users. Port mirroring helps us figure out what's going on in network by using a port analyzer. In order to capture packets for analysis by a port analyzer, we need to configure our switches for port mirroring. Back in the days of Layer 1 hubs, all ports could be mirrored because there was nothing stopping broadcast traffic between them. That made the network run slowly, so we moved up to Layer 2 switches instead. Now we could control broadcast traffic, but we could no longer analyze it for intrusion detection or prevention. Port mirroring was added so we could add this back in, but just on selected ports to keep the traffic down. We can set up the first port for the server we would like to monitor, and we can set up the second port to mirror that traffic to our intrusion detection system or intrusion prevention system analyzer. The packets are then analyzed, and the results are ported to a log file where we can view them and take further action. When we don't want certain traffic to get choked out by other traffic, we have to set up QoS, which stands for Quality of Service. Quality of service is a feature of routers and switches which prioritizes traffic so that more traffic can pass first. The result is a performance improvement for critical network traffic. Quality of service equipment is useful with VoIP phones or voice over IP in LANs where you've got a lot of volume or local traffic where certain types of traffic are more important than others. Quality of service is going to vary by switch and by manufacturer. The higher end switches that cost more, the higher network application layer it works with. And that basically means the number of queues differ as well as the kind of information that we can use to prioritize our traffic. If you have an unmanaged switch, you can't use quality of service. The traffic passes unaltered, which is why you need a higher-end switch, such as a Layer 3 aware switch or even a Layer 3 inter-VLAN switch that can allow us to set up QoS or quality of service. Many times I've set up quality of service for VoIP traffic, so that way when someone downloads a large file, they're not going to cause the phone calls to end up having dropped packets, which leads to confused conversations. IPS and IDS devices can definitely help us keep a handle on our network to make sure that people aren't doing things they're not supposed to be doing, whether it's hackers or internal staff. IDS stands for Intrusion Detection Systems, and IPS stands for Intrusion Prevention Systems, and they're both parts of a modern network. Many times they're on the same device, but sometimes they're separate. IDS and IPS compare network packets to a database containing known signatures of what's called cyber attacks. And then they flag any matching packets. So for instance, if you have a known attack and the packets match that attack, the intrusion detection system portion of an IDS IPS can stop that attack. Intrusion detection systems don't alter the network packets. Intrusion prevention systems, however, do. They can prevent the packet from delivery based on the contents of the packet, much like how a firewall prevents traffic by IP address if that IP address isn't allowed. IDS is going to monitor and report back to the administrator for further action, whereas IPS is going to do the prevention by blocking. In this graphic, we see real-time data from an IDS system called Snort, and it's an open source product. It's being sent to an open source Windows viewer called Barnyard that you can download from sourceforge.net. And we see more than one type of intrusion that's being detected here. These intrusions are matched to the signatures talked about earlier, similar to antivirus signatures for malware. However, this is just a notification, and the administrator is still going to need to perform any type of block based on the offending IP address. Here's an example of an intrusion prevention system on a web page that comes with the product from an open source product called Suricata. It also does IDS, but can perform IPS by blocking suspicious activity as it sees it. IPS and IDS can be excellent tools to prevent an attacker from getting through the door of any organization, and it should be part of all security toolkits. So if you have the option, make sure you get an IPS and IDS all in one system, especially now that a product like Suricata is available with open source software. We had a good conversation about VLANs, inter-VLAN routing, virtual private networks, got into port bonding and mirroring, and we also discussed quality of service to make sure that you have prioritized traffic. And then we followed it up with IPS and IDS devices to monitor and block any suspicious activity. All of these different subjects can help you obtain success in your Network Plus certification.